All right, this is our final investigation as far as erosion and deposition are concerned. And we're going to be testing one more variable, all right? So if you recall the last time we saw and we looked at the effect that slope has on how fast, how far earth material is eroded and it becomes deposited. Now we are going to observe floods, right? Floods are a mass amount of water more than normal coming down, right? And floods can happen because there's just a lot more water that is coming down at a faster rate. Also, floods can happen because the ground, the earth is already saturated, right? And by saturated, I mean the ground can no longer absorb any more water. There's no more water that the earth can absorb. So instead of water soaking into the ground and going in, it just runs off. All right, so that's what a flood is. So there's a few factors that can contribute to a flood. So we're going to look at the effect of regular rainfall, and also we're going to be testing flood conditions. So we're going to go to our journals and we're going to start in drawing our two representations. All right, so we're going to have our standard and our flood. All right, so again, same thing as before. We should be masters and experts on how to do this. All right, rectangle. Right, this is our tray. We're going to draw a little rectangle, a shaded colored in part that represents where the sand starts. The sand starts at 20 centimeters. All right, and then after we have our shaded, we're going to draw lines. We're going to indicate the 25 centimeter mark, the 30 centimeter mark, all the way to 50 centimeters. All right, label this one standard. All right, so then after you've done this, we're going to go to our other model. It's going to represent our flood. Rectangle. Shade in the area where the sand starts. It starts at 20 centimeters. Again, 25 centimeter mark, 30, draw lines, indicate, mark where it starts. All right, so what's different about this investigation? Mr. Bergen, what's going to be different? Well, if you notice, we have cups. We used cups. We started with our blue cup, right? This is our standard. And what you notice about this cup and how it comes down, there's a little hole. This is what we've been using for everyone up until this point. So we're going to use this one for our normal, our control. This will be for our standard one. But if you notice, the holes are bigger. Now we have our flood. The flood hole is bigger than the standard hole. So when I pour water in, this is going to represent what a flood like, where more water is coming down at a faster rate. So that's the only. And also, another difference is I use the sand from a different, a past experiment because, like I said, floods also happen when the ground is already super saturated and has absorbed a lot of water, and it can't absorb that much more water. So I use the sand from a previous investigation because it is already saturated. It's a little wetter than normal. So this one will be our flood, red dot. So the sand is a little more saturated. It's wetter. It has absorbed more water. This is our standard. This is our control. It is a drier sand, and the hole is smaller. All right. So now I'm going to pour water, and we are going to observe what happens. All right. So I'm going to pour in water to our flood. And then our standard. All right, what do we notice? What has happened so far? Granted, this one got a head start, but what do we notice about the runoff? Look at, what do you notice as far as the water trickling down, the erosion rates? We're still going. We're making our way with our standard. But look at the flood. Look at the differences in the water level of this cup. Water's still here. This one, it's almost empty. So what do you notice is different with the erosion rate, the deposition rate of a flood versus standard? All right. Oh. All right, our flood is basically out of water, but look at all the water that has built up in our flood tray, and our standard tray is starting to slowly trickle down. Let's look. Is there a valley? Is there a canyon? Any valleys or canyon in our flood? Valley and canyon with our standard. There's something that's interesting. I want to point your attention to our flood. Oh my gosh, my knees. Look at the angle where it came down, right? You can see the canyon. There's an angle. So it looks like this is higher ground and this is lower ground. So there must be something that's happening when more water comes as far as the valley and canyon that it creates. Think about that. All right, we're slowly getting there with our standard. All right, water is moving, so we are still dripping. But it looks like this has a much more defined canyon and valley. You can see erosion is taking place in front of your eyes. All right. Bird's eye view. You can see the difference in the canyons, valleys versus this one. It looks like it's kind of even. The ground is even on our standard. Again, flood is a little sloped. It starts angling down. Look at the erosion, right? We have the sand in the standard is kind of stopping, but we have sand farther down. Look at, we have sand particles much farther down. So it's about time to measure. So I'm going to put, all right, let's look. Okay, so we have it measuring. We started at 20 centimeters. Oh, some was eroded farther down, but a lot of our deposition is taking place at about 27. But if you want to be, you can say, all right, we traveled to about 35 centimeters. All right. Look at the valley, the canyon, the alluvial fan right here. I apologize for the camera work. It's hard when you only can film with one hand. All right. Now I'm transferring to our flood. Again, we started at 20 centimeters. Look at all the water buildup. We have a bigger alluvial fan right here at about the 24 centimeter mark, so only about 4 centimeters of erosion. But you see more chunks of sand that were pushed farther down the tray compared to our standard. So we have chunks of sand all the way at about the 43 centimeter mark. Now we don't have much of a valley or a canyon, but remember, if we look, this ground is higher. We have a higher ground that's sloped down from where this started. So think about that.